let's go through questions 13 and 14 on page 55 of the homework problems. So, page 55, number 13. So this problem says, on weekends, as part of his exercise routine, Carl goes for a run, and he runs partly on paved trails and partly across rough terrain. We're told that he runs at 10 kilometers per hour on the trails. So what I'm going to do there is I'm going to say the speed that he runs at, so S on the trails, or S on the, trails, or rough terrain, we'll say S paved, just to be a little bit more specific there, is 10 kilometers per hour. And we'll say S rough for the rough terrain is 5 kilometers per hour. So he runs partially on the paved terrain and then the rest on the rough terrain. So one day he's running 12 kilometers and it takes him 1.5 hours to do that. So again, some more info that we're told here. We're given the total distance is 12 kilometers and the total time is 1.5 hours. So this question actually relies upon a little bit of information that you would have learned in grade 9 science. So in the physics part of grade 9 science, you probably learned a formula which states that the speed that an object is traveling at is equal to the distance that it travels divided by the time it takes to travel that distance. Okay. Depending on who your teacher was, you may have seen this triangle. So I know this is a pretty popular way of explaining this formula. So you have S and then D up here in the numerator and then T down here. So you might have seen it written like that. Or, I mean, we can use our variables here. S is equal to D over T. Okay. So the two formulas that we're going to have to deal with here, we are going to have a formula that describes something to do with the distance, and we're going to have a formula that has something to do with the time. Okay, so those are going to be the two formulas that we developed. But first things first, let's declare what our variables are. Okay, so in this question, we're looking for how far he ran on the rough terrain. Okay, so in order to answer that, let's say let X represent the distance that he runs on the paved surface. Distance ran on the paved surface. And we'll let Y represent the distance that he runs on the rough surface. Represent the distance ran on the rough surface. Okay, so as I mentioned, we're going to need two formulas here, two equations that we're then going to use to solve. Okay, so the two equations that we're going to have, we are going to have an equation that tells us something about the total distance that he's running. So we're going to have a distance equation, and we are going to have a time equation. So equation 2 is going to be something that tells us something about the time. So time equation. Now the easier of the two equations here is definitely the distance equation. So we know the total distance that he runs on the paved surface and the total distance that he runs on this rough surface. When we add those together, we get a total distance of 12 kilometers. So our distance equation will be 12 is equal to X plus Y. So that's definitely the easier of the two. Now the time equation, we actually have to go back to the science formula that we would have learned in grade 9. So the physics formula, speed is equal to distance over time. And we want to rearrange that formula in order to get time. Okay, so if I bring this formula down here, S is equal to D over T, I want to rearrange this in order to get time by itself on one side of the equation here. So I'm going to first multiply time over to my left-hand side. So I get S, so the speed times the time is equal to the distance. And then I can take my speed and bring it over to the other side. So I divide to bring it over. So I get time is equal to the distance divided by the speed at which that distance is run. Okay. So the way I can formulate my time equation is by using this time is equal to distance over speed formula that I've developed here. Okay. So the total time that he runs, or the total time that it takes him to run, is 1.5 hours. And then this will be the time that it takes to run on the paved surface plus the time that it takes to run on the rough surface. So I'm going to just say t on the paved surface plus t on the rough surface. Okay. But then what I want to do is I want to use this formula to describe what t paved and t rough would be. Okay. So t paved would be the distance that he runs on the paved surface, so that is our x variable, divided by the speed that he's able to run on the paved surface. So he's able to run at a speed of 10 kilometers per hour on the paved surface. On the rough surface, he runs a distance of y kilometers, and the speed that he's able to run at on the rough surface is 5 kilometers per hour. So that is how we are able to find our second equation. Okay. Now from here you can use whichever method you would like to solve. So I'll use substitution. So I'm going to rearrange my first equation for, let's say we rearrange for x. So we get 12 minus y is equal to x. And then I'm going to take that and I'm going to plug it into my second equation. So I get 1.5 equals x, which I'm going to replace with 12 minus y over 10 plus y over 5. But looking at this equation, it's kind of messy, right? There's a lot of fractions, and it's not really nice to work with here. So a little bit of a trick, what we can do is we can actually multiply to try to get rid of the fractions. Okay, so notice that if I multiply everything by 10, so multiply by 10, what that will end up doing is getting rid of all the fractions. Okay, so let's see how that'll work. So 1.5 times 10, that gets me 15. And then I have 10 times 12 minus y over 10. Well, what that'll do is the 10 over 10, those will just cancel each other out. So I get just 12 minus y. And then I have 10 times y over 5. And again, we'll get some simplification there. All we'll be left with is plus 2y. Okay. So I don't actually think we saw that little trick in class, but this is an easy way of just getting rid of fractions when you're dealing with an equation like this. Okay. Now that our fractions are gone, we can just go ahead and solve this thing. So we have 15 equals 12, and then we can collect like terms here. So we have minus y plus 2y, so that's plus y. Then we just bring the 12 over to the other side. So 15 minus 12 equals y. 15 minus 12, that's 3, is equal to y. And then we can plug back in to solve for x. So 12 minus 3 is equal to x. So x is equal to 9. Okay. And that's it. So he runs 3 kilometers. Therefore, he runs 3 kilometers on the rough surface. And he runs 9 kilometers on the paved surface. Okay. So that kind of question is pretty cool, just because it brings in a little bit of physics, which we haven't actually seen before. So a little bit of an extension over the types of questions that we've been doing so far. Now let's get on to question 14 here. So I'll just... we'll just shift this over a little bit. There we go. So there's 14. So let's get this one started. This one's more of a number problem. So there's definitely less application with this problem. So two fractions have denominators 3 and 4. So I'm just going to write that down right away. So fraction 1, the denominator will make 3. So we don't know what that fraction is. We just know the denominator is 3. And fraction 2 has a denominator of 4. Okay. Their sum is 17 over 12. So what I'm going to do in this case, the ultimate goal of this question is determine the two fractions. Now, because I already know the denominators, really what I'm looking for here is just determine what the numerators are. So already I can write out my let statement. So let x represent the numerator of fraction 1. And we'll let y represent the numerator of fraction 2. Okay, so we have x over 3 and y over 4. Okay. Now, what we're told here is the sum of these two fractions is 17 over 12. So when we add fraction 1 plus fraction 2, the result is 17 over 12. So x over 3 plus y over 4, we add those two up, and we get a quantity of 17 over 12. We're also told that if the two numerators are switched, then the sum is 3 over 2. So we can call this, the equation that we just wrote down, equation 1. Now, if we switch the two numerators, so if we instead have y over 3 plus x over 4, when we add them up, the sum is 3 over 2. And so here we have our two equations that we now have to solve for, okay? Now again, the entire goal here, because we're adding fractions, the first thing that we should try to think about is finding a common denominator, okay? So let's start with equation 1 here, and let's just try to find a common denominator, okay? So it's pretty clear that the common denominator, the lowest common multiple of 3 and 4 will be 12. And so I'm going to have to multiply the first fraction by 4 over 4, and the second fraction I'll multiply by 3 over 3. And when I do that, I end up getting 4x over 12 plus 3y over 12 equals 17 over 12. And because I found a common denominator, I can simplify this a little bit more. So 4x plus 3y all over 12 equals 17 over 12. Now this is really great because if I look at the denominators on both sides of this equation, they're the same. That means if I multiply both sides of this equation by 12, what that'll do is it'll just cancel out the two denominators. And so this equation I can simply write as 4x plus 3y equals 17. And now what I'm going to do is the exact same series of steps just for the second equation. Okay, so again, I want to find a common denominator and then simplify it. Okay, so in this case though, if I look at the denominator on the right hand side, the denominator is 2. So I might have to do a little bit of work in order to get everything to have the same denominator like we had in equation 1. But first, let's apply the exact same common denominator steps here. So I'm going to still multiply the first equation by 4 over 4. Still going to multiply the second equation by 3 over 3. But then the fraction, the 3 over 2 on the right-hand side of the equation, in order to have everything have a denominator of 12, every fraction have a denominator of 12, I'll multiply this by 6 over 6. And that'll help me out there. So when I do that, we get 4y over 12 plus 3x over 12, and that will be equal to 18 over 12. And I can simplify this a little bit, so I get 4y plus 3x all over 12, and that will be equal to 18 over 12. And again, just like I did in the previous equation, at this step here, everything has a denominator of 12. And so I can just cancel it out. Or rather, if you want to be careful, multiply both sides by 12. And then I can cancel everything out. So what I end up getting here is 4y plus 3x equals 18. So what I've done here is by multiplying these equations and by finding a common denominator, I've created two new equations, or rather two equations that look new. It turns out that they're actually the exact same equations. I've just gotten rid of all the fractions. So I've just made the algebra that I'm about to do maybe just a little bit nicer. Okay, so what we can do here is we can decide what method we would like to choose. Okay, now in this case, actually, I would say we should probably choose elimination, just because if we try to use substitution, we're going to introduce quite a few fractions into the problem, and that it wouldn't be too bad, but it wouldn't be quite as nice, I think, as using elimination will be. So let's try to use elimination here. So I'm going to stack both equations on top of each other here. So I have equation 1 is 4x plus 3y equals 17. Equation 2, I'm going to rewrite this in order. So I'm going to flip the x term and the y term. So I get 3x plus 4y equals 18. And now what I'm going to do is let's aim to try to eliminate our x term here. Okay, so in order to do that, what I'm going to do is I'm going to multiply equation 1 by 3, and I'm going to multiply equation 2 by 4. So that'll give me two new equations that will easily let me eliminate our x variable here. So let's do that. So when I multiply through, I get 12x plus 9y equals now 17 times 3, 51. And I have, so my second equation, this is my updated equation 1. My updated equation 2 will be 12x, 12x plus 16y equals now 18 times 4, 72. And now I have two equations, and if I subtract, I will completely get rid of my x variable. I will eliminate x, I guess. So when I do that, 12x minus 12x, that's 0x. I have 9y minus 16y, so that will get me to negative 7y. And then I have 51 minus 72, and that will get me to negative 21. And so now I have an equation that just has y in it, right? I can ignore the 0x. So I'm just going to divide by negative 7 on both sides here. So I get y is equal to 3. Okay. Now I'm nearly there. I found my y variable. So I found the numerator of fraction 2. So now all I have to do is choose one of my original equations. So I might as well choose equation 1 here and plug in and figure out what x will be. So I have 4x plus 3 times y, which is 3. So I'm substituting there. Equals 17. So 4x plus 9 equals 17. 17 minus 9, when I move the 9 over to the other side, I get 4x is equal to 8. And I divide both sides by 4. So x is equal to 2. And I'm done. So I can conclude, therefore, fraction 1 is 2 over 3, and fraction 2 is 3 over 4. 3 over 4. And that's that. That is question 14. So hopefully that was a little bit helpful.